Now, the new stuff. Chapter 1. Chapter 1 is the beginning of the linear programming portion of this class. The next 4 chapters, 1, 2, 3, and 4, are all about linear programming. I wanted to kind of help you. I'm going to put linear programming in my own words. Linear programming, the hardest part of it is reading a story and picking out the numbers and the words and turning the story into equations. That's linear programming is. The part to apply the math to it, forget about that for now. That's when we get to chapter 3 or 2. For this chapter, it's about reading a story and turning the information you just read into an equation, maybe with a variable. You know, this is where the algebra comes in, because you got to say those words, turn it in. The first one, I think this one right here, easy one on your PowerPoint, all the way up to slide 21. This is about this person says, I want to write an equation that will help me figure out as fast as possible what the starting bid should be on a car. There should be something consistent about every car that comes to this auction that will allow me to quickly get to that starting bid. So we analyze past starting bids and what they ended up selling for, type thing, and what the car's original price was that came up for auction, looking how many miles did it have on it, how many years old it was, and find the average of all that stuff, and you should be able to put together a formula that will say if the car is this old, if the car has this many miles, if the car was originally this price, here's what the starting bid would be. And that's what this person wants to do. That's the thing. I want to come up with a formula to get there fast. So let's read and see how we did it. It says the auctioneer developed a simple math formula to decide the starting bid that will be required when auctioning a used automobile. Essentially, he lists the starting bid. Here we go. We want to know the starting bid is going to be equal to the starting bid at 70% of what the prediction is of the final winning bid. So 70%, I'm going to call it 0.70 times the winning bid. Now, we need to replace this winning bid word when we get more information. But right there, I just took one of the sentences and at least wrote out the beginning of an equation. The starting bid is going to be, by looking at all the past winning bids and realize, you know, that all these cars seem to start right around 70% of what they finished, what the winning bid was. Now, how do we predict the winning bid so we can get to that 70%? He predicts the winning bid by starting with the car's original selling price. Let's call that selling price. Well, let's call P. All right, P, selling price. So right here is going to have a P in it. That's what we call. I know it's on the PowerPoint. If anybody's looking at that, can you tell me what variables used for winning bid or for price, the original price? Is it just a P or a WP? P. Okay. Then it says the selling price and making 2 deductions. One based on the car's age. I'm going to call it A for age. Am I on track? And the other based on the car's mileage. So I'm going to call that M for miles. Okay. The age deduction that is noticed there is however old the car was, you could deduct about $800 for each year of its age. So now, age was, original price is P. So I'm going to take 800 times P. It says I'm going to be able to subtract from the original price 800 times however many years it is. And then I'm also going to subtract 2.5 cents for every mile that's on the car coming up. Anybody lose their homework? So I'm also subtracting 0.025 times the mileage. Is there a name on it? Grab it. I dropped it. Thank you. Okay. You ready? The winning bid is going to be the original price, which is P, minus 800 times, times the age. Where is everybody? Nobody caught that? The original price minus 800 times the age, minus 2.5 cents times the mileage. Then take the whole thing, multiply it times 70%. That's what I just got out of that story, so I'm going to write it like that now, and I'm going to use the variables we picked. 0.70 times the original price minus 800A minus 0.025 m. There it is. And now all I got to do is plug in something for P, A, and M, and I know my starting bid. So this is just introducing you to where you have to read a problem and pull out the information and write an expression with variables. Sure enough, we're using those variables. There's the winning bid, the original price, minus the age of $800, the mileage of 2.5 cents. Now we add the 70% because we really want to get to the starting bid, and there's our formula. If you read a problem on your first quiz and I said, write an equation that will get you to the starting bid. Use P for price, A for A, use any variables you want. I don't care. You can all use different variables. If it says, if I don't put on there what variables you use anything you want. But I'll probably say there's 3 variables. It's your first quiz. There's going to be 3 variables. Price, age, and mileage. Can you write the equation just like this? Because that's where we're heading right now for this first quiz. It's being able to write an equation like this. And they're not all just like this. There's break-even equations. And we're getting into where you're going to recognize things like objective function and constraints. That's where we're heading. We may not get that far today because we got to get some Excel. Next one. Oh, real quick. The car coming up now for bid is 4 years old. Put a 4 in for age times 800. It has 60,000 miles. Put that in for M. Multiply times 2.5 cents. And the original price, $12,500. I laugh because I can't imagine a car being $12,500 brand new. Original price, so we would put that in for P. 12,500 minus 800 times 4 minus, now, don't let this confuse you. What's happening here is if you get rid of the parentheses, 70% times 1 is 70%. 70% times 800 is 560. 70% times 2.5 cents is 1 3/4 cents. That's where those numbers came from, even though you don't see the map. You plug in the things. The starting bid for this car is $5,460. Winning price should be just whatever this came out to in the middle. It's the 70% that made it a starting bid. Okay, we're doing another one. Not that one. We'll do that one on Monday or Tuesday. This one, I think, going. Here we go. This one's even easier.
Can we go back for 10 seconds?
Yeah.
The .0175, where did that come from?
80%, I'm sorry, 70% of 2.5 cents
Okay.
is 0.0175. So the parentheses disappeared by multiplying 70% times each number of 1, 800, and 2.5 cents.
Then
All right.
quick question then, is
Yeah.
P the winning bid, or is
No,
P
P is the original price. The winning bid is everything between these parentheses. The original price minus the age times 800 minus the mileage. There's the winning bid.
Okay, all right.
Then you multiply times 70%, and now you have the starting bid.
Got it.
All right, you ready? This company builds one kind of house, right? They're new house builders. They only do one kind of house. And the selling price for this house is $115,000. All right? Land for this house is going to cost $55,000. Let's see. Land for each house costs $55,000, and lumber, supplies, and other materials run another $28,000 per house. With me? All right. I want you to put yourself in the mindset as the company owner of this business that builds these houses. And I'm going to ask you some questions. Accounting, all of you had a 201, 202 maybe already. I can't remember. But this $115,000 in accounting would be our revenue, correct? And then this $55,000 for the land and the $28,000 for the lumber, supplies, all the materials. Is this something we would pay for before we sell a house or after we sell a house? Which would it be? Before. No. There's no reason to spend all that money on the supplies, the lumber, and the materials unless the house is sold. And you've got to start building. And that's what makes it a variable cost and not a fixed cost. You don't have to buy all that stuff unless the house is sold. And you only buy what is necessary on how many houses you sold. But if you have an office, and you're paying a rent or a mortgage on that building, you gotta pay that whether you sell a house or not. And so that's a fixed expense, get it? All right, that's the question you ask yourself, if it's variable or fixed. When we write this up, you gotta have fixed and variable, and the variable has to be, all the variable expenses have to be multiplied by however many houses got sold to find that break-even point. You gotta break up the fixed and the variable, because we're heading to write an equation where you have the selling price, or revenue minus variable expenses minus fixed expenses equals 0. We want to find that break-even, or write an equation that will, and the variable is going to be how many houses do we have to sell to get that to 0. Get it? So we got to figure out that gross margin. All right, here we go. The selling price is $115,000, which is our revenue for each house. Use whatever variable you want, but if you're looking at revenue, it's $115,000 times X, or N, or P, whatever you want to use. Land for each house, $55,000, and other supplies is $28,000. Total labor cost is $20,000. Is that a fixed or variable? Labor cost, $20,000. Variable. We're not going to pay to have the house built unless we sold it. Right? We're selling houses first. Realize that. We're selling first, then building. So everything here is variable. We'll add them together with any other variable cost we have to get a total variable, and we want a total fixed cost also. We want those two separate. Next, Ponderosa has leased some office space for $2,000 a month, fixed or variable?
Fixed.
There you go, because we got to pay it even if we don't sell a house all month long. Cost of supplies, utilities, and leased equipment for the office runs another $3,000 a month, fixed or variable? Fixed. We got to pay that even if we don't sell a house. The one salesperson at Ponderosa Development is paid commission of $2,000 on every sale of a house, fixed or variable? That's right. Only gets paid if it's sold. The Ponderosa has 7 permanent office employees who have monthly salaries. Whatever they get paid, fixed or variable? Fixed. We have to pay them even if we don't sell a house. They're in the office, they're on salary, no commission, they get paid. That's overhead. And here it is, per month. 10,000, 6,000, 45, 55, 4, 3, and 2. All of those added together is your monthly fixed expense for that. You got to add it to your rent. That's a fixed expense. I think there was leased equipment, 3,000. There's another fixed expense to get that total fixed expense. Add all the variable expenses: the land, the building materials, the labor, and I think there was one other I can't remember. Oh, the commission for the salesperson. That was the other one that's variable. Add all those together. Break them up. Should get a total of blah blah blah. Let's see. Salaries are $35,000. The office space was $5,000 with supplies 2 and 3. So $40,000. There's our fixed expense right there. Break even equals something 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 equals 0. Mean revenue minus expenses equals 0. And then you use a variable. The variable is however many houses you're going to sell. Then you use algebra to get everything off to one side, leaving the variable all by itself, and you solved it. Most of the points that you showing me when you read a story like this, that you can write this equation right here. That's where the points are. And believe me, I can almost guarantee you there's a break-even problem on your first quiz, where you got to show me the equation that will get you that break-even. On a story that's almost just like this, using a variable in that equation. The variable is going to be how many will get you to that break-even. How many to cover all that $40,000 in overhead we're going to have without selling the house. We're making a certain amount of money off each one, but how much is that? We're selling for $115,000. What did all the variable costs come up to? Land, material, labor, the sales commission, $105,000. $115,000 times, let's go with H for house. I don't know. How's that? H, there's our revenue, minus, what's our variable cost? $105,000 H, minus our fixed overhead, $40,000 equals 0. There's the equation. There's where most of the points are. Then it's going to say probably, now show your work calculating the break-even, which means you've got to use algebra to get the H by itself. First thing I do, I put like terms together. This H and that H. 115 minus 105 leaves me with how much H? 10,000 H minus 40,000 equals 0. I'm going to add 40,000 on both sides to get it to the other side, trying to isolate that variable. So now I'm at 10,000 H equals 40,000 overhead. And now to get H all by itself, divide both sides by 10,000. Look what you just did. H equals, help me? Thank you, 4 houses. If we could just sell 4 houses each month, at least we're going to keep the doors open. Anything over 4 houses, we're making money and there's going to be a Christmas party. With alcohol. That's a lot of money. All right.
So are salaries and hourly, is that different if it's fixed?
It is different. If the person gets paid only because you sold a house, then that's how you treat it, whether it's hourly or salary or whatever the pay is. But if the person gets paid no matter if you sell a house or not, now it's fixed, no matter if it's hourly or salary or however it's being paid. It's all about you saying, if you were the business owner, would you have to pay that expense even though a house never got sold? And if the answer is yes, it's fixed.
So if somebody was paid hourly and they were working different hours a week or something, there'd be more
It's not rather,
fluctuation.
kind of.
It's still variable expense.
It's not, no, it's still rather, no matter how they're being paid and how often, it's still either only variable or only fixed. It's whether you have to pay them those odd amount of times, even if you didn't sell a house.
Gotcha.
Right? So if this person works 40 hours one week, 20 hours another week, 30 hours another week, do I have to pay them even though we never sold a house? If the answer is yes, no matter how they're worked and how they're paid and how many hours, it is a fixed expense.
It's the difference between commission and payroll.
Yes, because if they're on payroll, or which is salary, they're getting paid no matter what, even if we don't sell a house. But if they're hourly, because they're labor, and they only get paid if they're building a house, they're only building if we sold it. Now that's variable. We're only paying that labor. Now, there's employees who get paid to build a house, but now we don't have any house to be built, so they come in and work inside. Fixed variable. Because they would only get paid that job if we sold a house. But coming in here, we're paying them to do work even if we're not selling a house at all. You got to split it up. You're fixated on fixed being the same amount. Get that out of your mind. And usually it is. But there are fixed expenses that do vary, but it's still fixed because you have to pay it no matter what.
So how do you calculate that?
That's a tough one. With my budgets, I would estimate how many hours that person's going to average. I would estimate it. So it would turn into
Still
a
fixed, but it's not.
but in actuality, the numbers are different.
Gotcha.
Okay.
You kind of think about it as like building houses and skilled work. So skilled wages are a variable expense versus like the manager that
Like when
manages.
changeover takes place, when changeover, the skilled labor comes in. And you're saying some employees are getting paid one rate when they're doing a skilled labor job, but are some employees doing a different job getting paid a different rate then?
No, as in like,
Now you're too big in the shop.
yeah, see like, you know, like we build dies or whatever.
Yeah.
So like all the skilled labor that is actually building, like tools on the job, they're variable costs. But like the managers and supervisors, the forklift operators, moving everything around, they're all fixed costs.
Because they would be
They
the,
operate the building, they
Salary
manage
versus
everybody.
hourly.
Yeah, well.
it just happens to be that way, but it's not always that way.
Right, except for hourly that,
Like indirect labor versus.
yeah,
direct
indirect labor, like forklift operators, shipping receivers that have to be there no matter what, but they're not actually doing the work, building whatever. It's versus.
What I want to add to this is, when we subtracted the 115 revenue minus the 105 variable cost, that calculation is your gross margin. That tells you how much you profit from each house sale, and then that's the part you got to realize that's what's paying for the overhead. And then when overhead's 40,000, that means 10,000 goes to our overhead for each house sold. And once we get past 4, now we're finally making profit for the month. We got to sell 4 houses a month, we're breaking. All right, so those two, how are we doing on time? You have, we still got about 15, 20 minutes because we're starting our class early. You'll see why. Let's go to Excel. That's good. All right, let's say, now if this were a question on the quiz, you might have a picture of this, and I may say, hey, if this were a maxi max, and you wanted to find, you could use any cell, I don't know, and you wanted to find the maximum, and this is a payoff table, profit, and you wanted to find the maximum outcome for each decision, what would you write in the cell location to find the maximum outcome for decision 1? Everybody hear that? You're looking at this, and I'm saying let's treat it as a maxi-max. It's a profit table. I don't care which cell location you use, you're writing your answer anyway. What would you put in a cell location, any cell location, if you were trying to find the maximum payoff for decision 1? Always start out with the equals, and there's more than one right answer here, by the way. Go ahead.
Is it equal, max, colon, max?
I like the max. Max, and then what?
Colon, or no?
Colon?
Yeah.
I've never tried the colon. If there's a way to use colon, it's fine, but you got to identify what it's looking at.
Parentheses.
I go with parentheses also. But don't get me wrong, I know there's different ways of using some of these. So I don't automatically say, no, you're wrong, because I don't know, you guys probably are using it more than I am. By the way, when I was working every single day, Excel had not been invented yet. Wow. It was called Lotus 123, another company. Excel almost copied them. They should have been sued. Anybody ever heard of Lotus 123?
Yes.
You have. Yeah, you got to be pretty old. Not too old. I meant older than the average student. To be able to maybe have heard of someone mentioning Lotus 123. It was spreadsheets like that. And I can't imagine what they did before Lotus. Oh my God. When I did budgets, I don't know if you guys ever been Excel, I would have pages of numbers going out, columns and columns and columns and rows and rows and rows, doing budgets for every single department. But you always, almost everywhere I've ever been, you're doing budgets for 5 years in advance. You're planning cash for 5 years in advance. Is any accounting majors here? 1, 2, 3. All right, you're going to use this stuff a lot if you're going to get into accounting office. Now, decision 1, tell me the cells for decision 1 you would use. E5, 2, and then colon, and then you're saying G5, parentheses?
Yep.
I think that would work. That's the answer I'm looking for. If the question were, here's an Excel spreadsheet, you're using the cell locations that you see on the picture that you're looking at, and that's what I'm looking for. Ready? You've got an Excel spreadsheet picture there, and I'm asking you to give me the Excel equation you would write if you're trying to find the minimum outcome for decision 3. Hit me up. Gabriel, you ready? Equals.
Min.
Huh? Thank you. Min. Parentheses. E7. Very good. E7 colon. E7. That easy. We got the min and the max down, right? Anybody want to see another example? Real quick. Oh, here we go. You're doing your mini-max regret table, your regret table. And I want you to write a formula that does, hang on, I gotta think this through. Now remember, there's a couple ways of doing this, but let's see where you guys go with this. You're doing the mini-max regret, you're doing your regret table. I want you to tell me what would be in the, like if this is your regret table and you got 1, 2, 3 here, which represents 1, 2, 3, you got 9 cells. What is in that top left-hand corner cell? What would you write, looking up here, to determine what number would be right there on your regret table, the top left-hand corner? Think about the logic behind figuring out what numbers are used on your regret table. So I said, for the first state of nature, top left-hand corner, what would be in that cell? This is a little harder. Tell me the logic without cell location. How's that? Tell me the logic to find that regret you would use for that top left-hand corner. No. Oh, yes. Sorry. She's right. Because to find that regret number, the first thing you're looking for is the max for each state of nature. Now, and when she says max, it's because it's a profit table. Could be min if it's a cost table. But yeah, the max. So she's saying, look at the max of the state of nature. So let's start there, and then I'll erase it and we'll add to it. Max. First state of nature would be cell location. Help me out. E5. Is that E5? Thank you. Hey. Okay. E5 colon E7. There's just finding the max. Now there's more to it, right? Because you're not just putting the max on that regret table. What is it logically you're doing next once you've found the max? In this case, Excel is looking and going, 12. Now what?
Deduct every single.
From that, that's right. But we're only talking about that top left-hand cell. I want exactly what you would type in that cell for that regret number. First of all, tell me without cell location what you're doing.
Oh.
Okay, give me cell location. What do you want me to do?
I was gonna say you do like equal and then absolute, which is ABS. 'Cause
Ooh.
it's gonna be absolute.
Hang on. Absolute. I thought you were going to tell me minus.
Yeah.
Take all of that minus.
E5.
Is it E5? E5. Put the absolute. I didn't even think about that. Absolutely. Now, do I need another set of parentheses at all? Or will this work? I'll take that if it works. I don't even know. Is that absolute on Excel? I can't
Yeah,
remember.
you gotta go.
Oh, you gotta do ABS, don't
Yeah.
you? Sorry. Hang on. A.
And then you'll put another
B,
parenthesis.
S, I'm putting a bracket there,
Yeah.
and then will that work now?
I think so.
So the absolute value of the maximum from that column minus that number would be the top left-hand corner. So what number will appear right here if this is what we just put that in? 2. 12 minus, it will look up, find 12, then it subtracts that 10, puts a 2 there. That's what I need you to be able to do. By the way, there are examples of everything I just showed you on the PowerPoint doing exactly that. This is from chapter 13, right? And there's examples doing exactly what I just showed you, which is open PowerPoint while you're taking the quiz. But you need to be able to find that example quick. Go ahead.
Are we allowed to test it, like use an Excel sheet?
Absolutely. Just don't turn the internet on. You have your Excel open. You can do it in Excel and email me the spreadsheet at the end of the test. And I'll grade that instead. You don't have to write it out. It's up to you. Huh?
That's awesome.
I'll take it. Don't forget, though, you're not placing a number on that Excel sheet. You're putting in the formula, and I'm going to click on it and look at the formula and grade it that way. I'm not looking at your, just don't throw a number in there and you did it on the side on Excel or something. Put the formula right on the Excel spreadsheet. Anybody else?
So you're not necessarily looking for like the correct number, you're just looking for
Well,
the correct.
I am looking for the correct number, but I don't want you to put a 2 there
Yeah,
and think that's going to fly because you had it in Excel. You need to put in there
the formula.
the formula
To get that today.
AB equals ABS, bracket, max, and then it's so easy to know a 2 should be there. He's saying if it's not a 2, then he knows something's wrong with that thing, and he wants to check using Excel. But if you're going to check, you might as well just leave it on Excel and hand that in. Save a little time. Okay? How's that? Now we got to talk about Excel on inventory. Down here? No, darn, break even. All right, you ready? Anybody ever use the data tab on their Excel spreadsheet?
Yeah.
A little bit? All right. Here we're going to try to do the break-even. It's called a break-even analysis up there. I gave you step-by-step directions how to use this. And here's my example. Fixed cost. What's fixed cost here? Let's use this one. 40,000. Okay. Variable costs come to 105. Is that right? 105,000. Selling price is 115,000. Okay. Right now, we don't know how many houses we're going to sell production, but we do know that if you take revenue minus cost, our total cost is the fixed cost right now, I guess. Total revenue, total profit, loss. So what we're trying to do is, 10 is not this easy. We're trying to figure out what number right there, which would be the number that we would have to sell in houses to get the break even and cover that 40,000 in fixed cost. Step 1, select the data tab, right there at the top. Step 2, select what if analysis. Where is what if? There's analysis right there. If you don't have what if analysis, go to your Excel help, put install what if analysis. It'll give you a little thing how you go file, options, add-ins right here. You just follow it step by step and get that if you want it. Also, this other one over here where it says solver and data analysis, you're going to need this also. And most of you will not have that in Excel. Do the same thing. Go to your help, install data analysis. It will tell you to go to file, again, options, add-on. It will tell you step by step. Oh, almost closed. Step 2, select the what if analysis. Step 3, select goal C, right there. Select goal C, then it says enter the total profit loss cell location. Profit loss cell location is going to be D17. Here we go. D17. Then it says enter 0 to the total to value, because we want it to break even. We're saying we want you to tell us how to get to 0 profit or break even. And then it says enter the production cell location right here. So this is where we would have D11. And that's where we want our answer to tell us how many to break even. It should come up with a 4. You ready? Hit OK. And sure enough, there it is. 4. 4 houses to break even. It will give us 460,000 revenue, cost with variable and fixed, takes us to 0. So you now know how to use the what if, the break-even analysis in the what if. Now the last one that I don't have open is I wanted to show you an inventory. How much time we have? Now I'll show you inventory on Monday. Instead, we're going right here. Oh, let's do this one. You ready? Now. Some of you haven't done an if statement on Excel in a long time, and some of you have done it all the time. I want to review an if statement and make sure you realize how it's done in these last couple of minutes we have. Are you ready? In Excel, equals if, parenthesis, now it has 3 parts. This first part, and then a comma, is what you want Excel to do a logical expression. Something like, look at a cell and tell me if it's less than or greater than, or you're actually, the expression you're writing is where you want Excel to say whether it's true or false. And you could say, hey, look at cell E5. Is it equal to 10? Okay, is E5 equal to 10? I'm going to put that right now. E5 equal to 10. There's the logical expression that I want Excel to check. Go to E5. Does it happen to be equal to 10? If the answer is yes, it's true, you tell what you want to do right there. Comma. If it goes back and looks and E10 is not equal to 10, then you want to tell it what to do, parenthesis. So it's the logical expression, what you want Excel to do if it's true, what you want Excel to do if it's false. If that cell is not equal to 10. So, just to show you how it works, equals. If, parenthesis, E10 equal, not E10, E5, 5 equal to 10, comma. It is equal to 10, but I'm going to use quotation, yes, comma. Well, what if it's not equal to 10? About no, parenthesis. Well, NPO, whatever that stands for. All right? What should show up here now if I did it right?
Yes.
Sure does. Hang on now. What should show up now if I did it right? All right. Write what these 3 sections are, because I simplified the things that this could do so much so, when you get the hang of this, I've written if statements that have gone, lines. Because I have, if this is true, I want to do this. But if it's not true, I want to ask another if statement. And if that's, now if it's true, do this. But if it's not true, I have another if statement. I need to pinpoint what's going on. And finally, when it is true, and when I went through every one of them and none of those are true, then it has to be this, do this. And they end up being lines long. But they're very creative. It makes Excel allow you to do almost anything you want to do. And the key, accounting majors, are you ready? Always use cell locations on all your formulas. Try to never use numbers. It just makes your life so much easier. You have to update your budgets, accounting majors, when you get to the point of running an accounting office. You have to update your budgets every month. And to go in and just change one number and watch all the spreadsheet change instead of having to hunt down all the places you got to change that number makes life so much easier. So you got to know Excel and understand how to write everything with cell locations, not numbers. All right, we're getting ready for our earning class.